I am Dr. Jarumati. I am senior resident and fellow in Hospital Infection Control, JIPMER. I am the region coordinator for this Fosfomycin study. I welcome all the centers who are interested to participate in the study. Now we will have a elaborate discussion on the protocol of this study. I will share my screen. Okay. The title of this study is AMR surveillance and antibiogram of parenteral fosfomycin for enterobacterials and comparison of various testing methodologies. So we have different objectives of this study. So the primary objective is to estimate the antimicrobial susceptibility, that is S percentage of enterobacterials against parenteral fosfomycin using modified Fosfomycin Agar test. And the secondary objective is the comparison of VITEK to Fosfomycin susceptibility test results with the modified Fosfomycin Agar dilution test for the parenteral fosfomycin. And we are also going to compare Kirby-Boyer distribution susceptibility results with modified Fosfomycin Agar dilution test for parenteral fosfomycin. These are our objectives of the study. So coming to fosfomycin, so we have, as Dr. Ketan sir told, fosfomycin is having various indications. We have different formulations of fosfomycin, that is oral formulation we have and IV formulation we have. So oral formulation is recommended for lower urinary tract infection, cystitis, and IV formulation is usually recommended for systemic and other infections involving XDR strains and carbapenem resistant organism strains. So what are the testing methodologies there? Okay, disk diffusion is like available for the methodology can be done for urinary E. coli and also Enterococcus fecalis isolates. And agar dilution is the gold standard, like it's the only recommended MIC method for fosfomycin. The BMD method, broth microdilution, and E-test should not be performed for fosfomycin. Okay. So these are the guidelines. Fosfomycin guidelines, various guidelines like CLSA and UCAS, what these guidelines say about fosfomycin susceptibility testing. So CLSA, what CLSA says according to 2023 like guideline is, it is giving only for E. coli. E. coli urine isolate, they are giving the breakpoints. Both distribution breakpoint and MIC breakpoint they are giving. Whereas if you see UCAS guidelines, we have distribution breakpoint, and distribution breakpoint is for E. coli, for urinary isolates we have, and this UCAS is giving separately for oral IV. Like this CLSA doesn't say about oral IV and all, just they are saying E. coli breakpoint for urinary isolates. But UCAS having separate breakpoint for oral and IV. IV formulations. Like for this distribution, E. coli urine distribution is there, and MIC breakpoints also there. This is for urine. For other specimens E. coli, we have distribution breakpoint, but for other specimens MIC also we have. UCAS MIC is there for other specimen enterobacterials, not only for E. coli, enterobacterials also we have MIC breakpoint for fosfomycins. So now what breakpoints we are going to use in our study is this breakpoint we are going to use for our study. According to UCAS, we are going to follow this UCAS distribution breakpoint and UCAS MIC breakpoint we are going to follow in our study. For all the specimen, all enterobacterials isolates we are going to use this breakpoint only.
One thing I like to add here is that you may have a doubt subsequently, but the rule for this study has been defined that the disk diffusion, that Saru will tell subsequently, disk diffusion you have to perform not only for urine E. coli isolate, you have to perform disk diffusion for the purpose of study all enterobacterials and all clinical specimen. Okay, and same Fosfomycin MIC based study, what we'll be describing you, that also need to be performed for all enterobacterials and all clinical specimen. This is for all. You need not restrict your disk diffusion testing only for urine isolate and not for others. Breakpoint, what Saru has already told, this is what we'll be recommending and we'll be using for interpretation. You in the entry screen, which subsequently will show, in those entry screens, you have to perform all the in all the places you have to write your zone diameters as well as MIC value in the entry sheet. Testing subsequently, we plan, that Saru will describe you, in such a way that all the ranges are covered nicely. So if you look very carefully in this, what Saru has already told, the minimum point MIC is 8, and then we have 16, then we have 32, then we have 64, then we have 128, and then we have 256. So in this study, the range of testing is decided from the minimum, which is susceptible breakpoint, to the maximum resistant breakpoint. So we'll be planning the study in such a way that we cover an MIC of 8 to 256. Okay. This is one point that we'll be discussing subsequently. I told it here because where we have a breakpoint range here. So this, you remember, we'll plan this test in this range so that everything which is available as a breakpoint will be covered. Okay. There is one more reason for covering this range that Saru will be telling subsequently. 8 to 256. Okay, go ahead, sir.
Thank you, sir. So inclusion, what is our inclusion is, as Dr. Ketan sir told, all enterobacterials from all clinical specimen isolates we are going to include in the study, and minimum number of isolates is 100, but the centers can keep on entering they can keep on submitting the data of the testings. And what are the methods we are going to do? 3 methods we are going to do. One is a modified agar dilution test. The other is disk diffusion, and third one is VITEK 2. Like for enterobacterials, if we have put 405 panel, that Fosfomycin MIC we can take. Suppose if you have put 406 and that Fosfomycin MIC also you can take for the interpretation. And data entry we are going to do through spreadsheet based entry for all the centers individually. Coming to the modified agar dilution test, as I told previously, the agar dilution is approved method, MIC method for testing Fosfomycin. So here we are using the agar dilution plates, which is added with the 25 microgram per ml of glucose 6-phosphate. For Fosfomycin, we need a glucose 6-phosphate to be included in the agar plates for the testing. Okay, how we are going to do the modified agar dilution test? So this is like using limited number of plates. Instead of a regular agar dilution, where we have to use all the breakpoints, available breakpoints, starting from 1 to 4, like all the twofold dilution we have to include in regular. Instead of that, we can use whatever the breakpoints if you need for this modified agar dilution testing. Here we are going to use 5 plates in our study. So 8, 16, 32, 64, 128. As sir told, like it covers all the breakpoints given by both CLSI and UCAST breakpoints. This 5 breakpoints, by using this 5 different plates, we are able to record the MIC in the range of less than equal to 8 to more than equal to 256 microgram. So like if the growth is not there in 8 microgram, our starting microgram is 8 microgram. If the growth is not there in that plate, it indicates that the MIC should be less than equal to 8 microgram. And if our 5th plate is 128, if the growth is not there in 128, it indicates that the MICs may be more than equal to 256. So it covers MICs in this range. So materials that we have to purchase for the study, one is a Fosfomycin drug powder, 5 grams we need for the entire study. It will go beyond 100 isolates, like maybe it may cover 200 up to 200 isolates if you use it carefully. And this is the like price of this Fosfomycin powder. 5 gram powder price is this. Different also available, 1 gram, even 50 grams also available, but we recommend 5 grams to be used, to be purchased. That will be adequate to do the testing sufficient for this study. And glucose 6-phosphate is another important thing, that is 5 gram. It is around 9,000. That has to be purchased. And Fosfomycin disc. Fosfomycin disc, like high media disc, can be purchased. Okay, this disc contains 200 micrograms. Like this disc itself contains 50 micrograms of glucose 6-phosphate. These are the material to be purchased. The coming to the preparation of the drug plates. Now, this is a scheme for that should be included for one plate, one drug plate. What and all to be present in the plate, that I will tell in this slide. And subsequently, how to go about the study, that I will tell. First, for preparation of one plate, what and all materials required? First, we need a molten MHA plate. Okay, MHA in molten MHA in molten state, like around 18 ml we have to take. This to be added with glucose 6-phosphate, and according to recommendation, 25 microgram per ml to be included in each of the drug plates. So if you calculate this, 500 microgram per ml, so for 20 ml we need 500 microgram to be included in a single plate. And for that, if you calculate 10 microliter of the stock solution 50 milligram per ml to be added in each plate. Okay, finally 10 microliter to be added in each of the drug plate. And coming to Fosfomycin drug, working drug solution, this 2 ml to be added. Drug molten MHA should be added 18 ml plus the drug solution should be added 2 ml. Totally we are getting 20 ml per plate. We have to pour the molten MHA agar of 20 ml into each plate. Okay, to that we have to add 10 microliter of glucose 6-phosphate. Okay, this is the composition of each plate. Okay, this I will tell in how to prepare this drug working drug solution, that I will tell in the subsequent slides.
What we need to do is just one point here, is that if you look into the dilutions, the 2 ml of drug, what already we tell, is ultimately becoming 20 ml of media plus drug. This 2 ml is added to 18 ml of agar, that will become 20 ml media plus drug. So what is the dilution? What is happening in the drug? How much the drug is getting diluted? 1:10 times dilution is being done. Because of this 10 times dilution, if you need a 8 concentration of plate, you have to prepare 80. If you need a plate where final concentration is expected to be 16, you have to prepare a drug concentration of 160, because 2 ml is becoming 20 ml with a dilution of 1:10. So all the drugs which are final concentration which are to be tested, the working need to be always prepared in 10 times the concentration. Okay, this comes from here, 2 ml becoming 20 ml. That's why we prepared 10 times the final concentration to be tested as a working solution. This is the working drug solution. Subsequently, we'll explain it, how preparation of plates can be done. Okay, sir.
So now we will go one by one. How to prepare the stock solution. Stock solution. So you will be having the powder in hand. After purchasing, you will be having the powder in hand. And first you have to prepare the stock solution, which is having the concentration of 10,000 microgram per ml. So to prepare this working stock solution of phosphomycin, first, so it's a simple way I'm telling. So just first add 100, just measure the weight of 100 mg of phosphomycin disulfate salt powder and add it in 10 ml of sterile distilled water. Our diluent is sterile distilled water only. 10 ml you take sterile distilled water, weigh phosphomycin powder of 100 mg and you have to mix it properly, and finally you will get 10 mg per ml, which is equivalent to 10,000 microgram per ml. In terms of microgram, it is 10,000, and in terms of milligram, it is 10 mg per ml. This is the stock solution. This stock solution you have to store in minus 80 degrees Celsius. Minus 80, you have to store this. So you have prepared the stock solution of 10,000 microgram per ml. So then we have to go with the working solutions whenever you are going to do the test. So how to prepare the working solution of phosphomycin? For phosphomycin working solution to be prepared in a like amount of 10 ml you can prepare for each dilutions. Okay. As I told, there are 5 different concentrations, and as the drug is getting diluted 10 times in the molten MHA agar plate, so we are taking the drug concentration into 10. So 80 microgram we have to prepare the working solution. So while adding it in the MHA plate, it will become 8. So for getting 80 microgram per ml, so we have to take from the stock solution, you have to take 80 microliter and add it in 9,920 microliter of sterile distilled water. This is the, so like 10,000 microliter you have to take, and from that you can remove 80 microliter and add 80 microliter of drug concentration. That you can do. 10,000 microliter you have to take the sterile distilled water, and from that first you can remove 80 microliter of sterile distilled water and then add with 80 microliter of our drug. From stock solution, 80 microliter you can add. Okay, this is how to prepare 80 microgram per ml. Like this, from stock solution, we have to take 160 microgram. To prepare 160 microgram, we have to take 160 microliter from the stock solution and add it in appropriate amount of sterile distilled water. So 160 microliter of distilled water can be removed, and 160 microliter of drug from the stock solution can be added to get 160 microgram of working solutions. Like this, so 5 different working solution we have to prepare. And glucose 6-phosphate stock to be prepared by adding 50 milligram. We have to measure 50 milligram of glucose 6-phosphate and add it in 1 ml of distilled water, and this is the stock solution for glucose 6-phosphate. So we have now prepared the working solution of phosphomycin from the stock solution, and now we have prepared glucose 6-phosphate stock solution also. Now going to the preparation of drug plate. For preparation of drug plate, you have like now we have to prepare the 6 petri plates, including growth control. Growth control is the plate without any antibiotic. No antibiotic will be there, just to check whether the organism is really alive or not. We have to include, without the drug, the organism is growing or not. The organism should grow in the drug growth control plate. So apart from growth control plate, we have to prepare 5 plates. Okay, and we can prepare 100 ml molten MHA up to the concentration of 100 ml we can prepare, so that we can use we can pour it in many petri plates and keep it for future use also. So now I will tell how to go about preparing the drug plate for 100 ml. So 100 ml plate, so 100 ml McCartney bottle we have to take. In each McCartney bottle, we have to take 90 ml of MHA molten agar and plus 10 ml of working drug concentration. So this will make up to 100 ml of the molten MHA, and this 100 ml can be poured into 5 different plates of each for single drug concentration. For example, you have to prepare 80 microgram per ml for 8 microgram per ml. Okay, this 100 ml amount you can prepare and pour it in 5 plates of 8 5 plate, all 8. So other plates you can keep it for future use. So in one go you can prepare 5 plates of a single concentration. Okay, like this you can prepare for all the concentrations. So like for preparing 8 microgram, 90 ml MHA plus 10 ml of 8 microgram plus 50 microliter of glucose 6-phosphate to be there in the McCartney bottle that we have to prepare, and from that 100 ml we have 20 ml pour in each plate. So 5 plates you will get of 8 microgram per ml. So 5 plates you will 4 to 5 plates, approximately 4 to 5 plates you will get. So 4 to 5 plates of 16 you will get 32, 64, 128 if you follow this. So while doing the procedure, we are sharing the protocol also, the PPT also. Just you can take the snapshot of this, keep it pasted in the lab so that while preparation, like you will not miss any concentrations. Sometimes you may miss adding glucose 6-phosphate in some concentration, so that should not be done. So all these plates should contain everything. So, and the final growth control plate will not have the drug will not be there, just 100 ml of molten MHA plus and glucose 6-phosphate also not required, just 100 ml of molten agar that can be used as a growth control plate along with the drug concentration plates. Okay.
So while you have to do it, you just have to take a printout of this page, stick it to your media room. But you have to tell clear cut. It's very easy to prepare plate for technicians also. So you just take a picture of page, only this page, put it on the media room. Instruct your technician to take 5 McCartney bottles. Minimum volume required is 100 ml. What he has to do, he has to put 90 ml agar mixture in all. Then full 5 plates he has to put in autoclave. Autoclave as usual, how he does it. From once it is brought out of autoclave, it should be put in a water bath. Water bath may you have to set the temperature of water bath somewhere around 45 to 50 degree. Let it come down from 121 temperature of autoclave to this. Once it stabilize, usually it takes some 15 minutes or so to come to the water bath temperature, 10 to 15 minutes approximately. It is brought out of the water bath. Then this 10 ml drug is added in each concentration. Like here I have added from 80, here I have added from 160, here I added from 320. 10 ml each I am going to add in each. Similarly, you can label this as similar way so that you remember which to add in where. And then after that, you have to add just 50 microliter once in each. One pipette, 50, 50, 50, 50 dispensed, the G6P. And one such can be used to prepare either 4 or 5 plates, whatever is possible. That's for a technician, understanding it's not very tricky. Preparing of drug concentrations is to the tier one. Preparing of plates is very easy. You just have to stick this page to your media room and basic instruction to your technicians. Okay. Okay, sir.
Okay, now we have the drug plates. So we have the isolates now. All our inclusion criteria, as per inclusion criteria, enterobacterials from all specimens we are going to include. So for how to prepare the test inoculum. So first bacterial inoculum is first prepare and match to 0.5 McFarland's. 0.5 McFarland is how much? It is approximately equal to 1 to 2 by 10 to the power 8 colony forming units per ml. So if you see for per microliter, how much it will be? It will be equal to 10 to the power 5 colony forming units for a microliter. So this 10 to the power 5 colony forming units per microliter has to be diluted 50 times. For making it 50 times, from this 10 to the power 5, you have to take 10 microliter of 0.5 McFarland inoculum, which has to be added with 490 microliter of the sterile distilled water. So by adding so we are diluting this 10 to the power by 50 times. So we are getting now 2 by 10 to the power 3 colony forming units per microliter. And from this, we are going to add 5 microliter. And usually pipette is recommended. You can aspirate 5 microliter from this concentration. 2 by 10 to the power 3 colony forming units. You can take 5 microliter. And that with the help of a pipette. And you can make a spot of 5 to 8 millimeter. This is the plate. So you can divide the plate and you can use the pipette and you can make a spot of 5 to 8 mm. Diameter, you can make approximately this much diameter, you can make the spots. In like a checkerboard fashion, you can do the spot. And on all on 5 drug plates, as well as the growth control. Growth control is very important. All the isolates you are testing, growth control also to be included. Only if the growth control organism is growing only, you can go on to evaluate the other plates. If growth control itself, growth is not there, you should not see the other plates. And very important thing is within 15 minutes of inocular preparation time, you have to add the you have to make the spot into the MHA plate, whatever you have drug plates you have prepared. So you have to incubate. So finally, how much you are achieving in the drug plate? So you will, by making a spot of 5 to 8 millimeter from like we are going to put a pipette 5 microliter of inoculum into the plates. So you will, the final drug concentration, the inoculum concentration that is reaching on the plate is 10 to the power 4 colony forming unit per spot. You will achieve this concentration. This is the recommended spot for colony forming unit per spot for agar dilution. Then you have to incubate overnight at 37 degrees Celsius. Then reading has to be done. How to record MIC? It is the lowest concentration of antimicrobial agent that inhibit the growth of test inoculum. Like this is series of plate 8, 16, 32 you are using. So you are getting a growth here, and you are not getting a growth in 8 microgram. Your growth is there, visible on the next day, and 16 microgram the growth is not there, means 16 microgram will be your MIC. And all the plates also the growth should not be there. So like this you have to interpret the lowest concentration that inhibit the totally the growth of the test inoculum. Here we don't have growth, so 16 microgram is our interpretation. So like this you have to record the interpretation. So Coming to the distribution, as I told, high media, you can purchase the disc which is containing 50 microgram of glucose 6-phosphate, and for we have to include all only, even though like E. coli, only E. coli breakpoint is there, and we have for other isolates like Klebsiella, Enterobacter also we can use the E. coli breakpoint for other specimens for interpretation of distribution for our study purpose. So coming to the QC, this is the QC range from CLSI distribution QC, and E. coli 25922 you can use. For MIC, we can use E. coli Pseudomonas, Staphylococcus enterococcus. These are the various QC ranges available in CLSIs. You can use these QCs, which can be included in all the plates, all the drug plates, growth control plates. So the same QC strains you can include. And before the interpretation of your test strains, QC strain has to be seen. The growth of QC strains to be seen in all the drug plates. So coming to the VITEK, so how this we have to compare it with VITEK. So we have a calling range for VITEK. How much values, how many different values VITEK interpretation can give. So for 405 also having Fosfomycin in the panel, 406 also having Fosfomycin in its panel. So both are going to tell the MICs in the range of less than 16 to more than 2, less than equal to 16 to more than equal to 2. This range it will cover. So our modified like Agar dilution method, we are going to get the MICs that we are going to compare with the VITEK, what VITEK report is telling. Yes, sir.
This is our range. Yes. Yeah, this is the range where we will be testing our in this study. We'll be testing it in the MIC range of less than equal to 8 to more than equal to 256 using 5 plates. 5 plates of 8, 16, 32, 64 and 128. So this is one, I told you we have 2 reasons of testing in this range. One of the reason was we wanted to cover all the breakpoints available for CLSI. The other reason is once you evaluate your modified Agar test with VITEK result to see if VITEK is reliable or not, there are 2 ways to evaluate it. One is what we call as categorical agreement, and another way to evaluate is what we call as essential agreement. Now, essential agreement you can ascertain only if your test method, what is VITEK in this case, and your gold standard method, which is modified Agar test in, must be tested in this almost same range. That's why we have to test 5 plates so that the MIC range of this is taken into account. It will help us calculate the essential agreement for VITEK. VITEK in both the panel, the calling range or the reporting range is in 16 to 20 to 56. That's why 5 plate testing will be followed. Okay, sir.
From the actually going to enter our values in spreadsheet for each center. In center, separate spreadsheet you are going to maintain in your lab, in your system. So from that, from your VITEK report, either it is a 405 or 406, whatever panel you are putting, the Fosfomycin MIC will come. This MIC along with the interpretation you are going to enter in your spreadsheet for each isolate, sir. The spreadsheet, how you are going to enter, that I will show you. I will share the screen. So this is the spreadsheet that each we are going to share with all the centers. So so each center will be entering like the values like this. These are the different parameters. The first top row is the different parameters that you are going to write. So first column will be your VAMR code. All centers will be having only that your individual code will be there. So that you are going to repeat in all the rows. Okay, then the sample number you are going to write here. Specimen, whatever specimen you are getting the enterobacter, that you are going to pass like urine, blood, whatever specimen you are going to write here, and the enterobacter's name, E. coli, Klebsiella, enterobacter, whatever it is, that organism name you are going to enter here. And the what is a meropenem? This now currently no need to like analyze this. Like just finally this will be helping in your in our analysis. So meropenem, whatever interpretation you are going to give for meropenem, if you are getting the VITEK report, meropenem, imipenem, metapenem, whatever interpretation you are getting, that interpretation you are, whether it is S, I or R, that you are going to enter for each of the isolates. So one row is for each isolates. So one entire row is for one isolate you are going to record. One by, if you per day you are testing 3 isolates, phosphomycin means 3, like 3 row you are going to use. For that you have to repeat the VAMR code and different sample number and specimen type, organism name, and this meropenem, imipenem, ertapenem interpretation for each of these isolates you are going to write. And then coming to the testing methodologies. So 3 methods. The first, the pink colored one is a modified agar dilution, MIC, with its interpretation. The green colored thing is distribution. Zone diameter is very important. In terms of millimeter, the vernier caliper you can use to measure zone diameter. So exact zone diameter you will get, that you have to write here. Along with the interpretation also you have to write. And VITEK MIC, like how I have shown the VITEK page, from that MIC you can get, and VITEK interpretation can be written in this. So these are our 3 testing methodologies. The MIC or zone diameter range, the value with the interpretation you are going to record in our spreadsheets. So each center, so separate spreadsheets to be used, that will be shared frequently. How frequently, that we will let you know. And while like in starting you will be having doubts. That time, like then and there, you have to clarify the how to any interpretation or entering doubts you have, you can clarify it then and there. And how frequently you have to share with us, that we will let you know. That's it, sir.
Okay, so now this session is open for discussion and queries addressing. So we'll love the centers to ask their queries, anything and everything regarding this study planning.
Sir, Dr. Vidya from VAMR Hospital.
Yes, ma'am.
So do we need any resistant isolate to be checked as a control?
Not needed, ma'am. The recommended QC strains, especially if you test for MIC, including Pseudomonas ATCC and Enterococcus faecalis ATCC, makes more sense. Any of them you can use, but the range, MIC ranges where we are testing, it's better to include
Sir, Ketan sir, your voice is breaking. Ketan sir, you are on mute.
Sir,
Can you
was I audible when I explained the query?
No, sir.
Or
No, sir. Actually, we can't
No,
hear
sir,
you.
only
Can
your
you-
audio.
Okay. So what I told is no need of testing any resistance strain for QC of fosfomycin. What is the recommended TLSI 1 is enough for testing. As far as MIC is concerned, the best to test is Pseudomonas and Enterococcus faecalis, because it fits in best with our ranges what we test. And as far as disk diffusion is concerned, we can simply go with E. coli ATCC and staph aureus ATCC. That will be enough. And all these 4 strains are available with, I think, all of our centers. Nothing to be included extra other than these. Am I audible or I'm lost again?
You are audible.
Okay. Any other center?
Okay.
Anyone who has any doubt?
So right now, are we going to proceed with any enterobacterate or especially carbapenem resistant enterobacterate?
No. This we are doing for all enterobacterials, ma'am, not only carbapenem resistance. Subsequent analysis will be done on all enterobacterials as well as a subgroup analysis on only carbapenem resistant ones. That's why we are collecting the carbapenem resistance data also. But to begin with, the study will be performed for all enterobacterials.
Ketan sir, E.
Yes.
coli, Klebsiella, and Enterobacter, these three things are most common. That only we can include, or other Enterobacteria are required.
Most common we get this only, but no need to specifically ignore others. What can be done is CAT, the Colistin Agar test, and Fosfomycin plates. These can be a routine part of your implementation, so that whenever a gram-negative isolate of enterobacterials comes, the required technician should have a reflex putting of a spot for Colistin Agar test as well as a spot for Fosfomycin. So this is what we expect. No need to exclude any other enterobacterials. The only problem is you may have to wait if you don't have the ID on the given day. So if you have ID which is available immediately, it's easy for you because you know the ID and you along with your AST you decide what to put. The problem is if your ID comes along with VITEK ID and AST, then subsequently once that is identified to be enterobacterals, you have to put that.
Sir, first
Yes.
consecutive isolates of Enterobacterials excluding Salmonella, Shigella, like this.
Yes. Salmonella, Shigella are definitely out of this. Salmonella, Shigella has a different testing panel altogether. So that definitely not to be included in this.
Sir? Ketan sir?
Yes, ma'am.
Sir, actually, you are saying every day you add cat and Fosfomycin Agar, but
Yes.
is that thawing and freezing is okay, sir? Because it's a checkerboard, we won't get all the isolates for a plate at a time, no, sir.
Now, what you can do if suppose you are a small throughput system where you're not getting sufficient gram negative. Suppose you are a system where you get 5 or 6 or 8 isolates of gram negative on a daily basis. It is all specimen testing. So you include all the specimens. Suppose you are a high throughput system where you at least get 5 or more gram negative. What you can do is you can have a growth of that. Put 5 spots, keep the plates in the incubator. Next day from the incubator, you bring out the plate, keep continuing plates in that. You need not, in the same plate, it goes to the incubator, comes out next day, spots are made in the subsequent way, in the serial order. Okay. This is how it is done. Plates always go in the incubator. In the next day, it comes out whenever you want to prepare for the next 5 or 6 or 10 isolates. You continue from wherever you've ended. For those centers who are a small throughput center where 1 or 2 gram negative bacilli come or less than 5 bacilli come in a day, what they can do is they can keep up the plates and after 2 days they can put the spots simultaneously for some 4 5 isolate or 6 isolate. Or if they get more or less number of isolates in 3 4 days, you get 5 6 isolates gram negative isolate. I don't think that low it will be your organism count. But if suppose you are in that way, then you can pull up few samples and do it. The only thing required is if you keep an isolate which is not overnight, you must first enrich that organism in a growing media, let them come in the log phase, and then only you can use it to prepare your inoculum. That broth inoculum preparation method, that is recommended if your plate is more than 1 day old. If that is the only recommended method.
Then we should divide how many urine and how many non-urine enterobacterial, because generally urine enterobacterial numbers will be pretty high. if you don't define that, then centers will end up in submitting more of urine isolate, less of a non-urine isolate.
Can be done, sir. Like the minimum 100 isolate, we have told that we can keep as minimum of 50 non-urine enterobacterial isolate. I believe centers will be, if they once they start doing it, they'll be doing it for more number of isolates. But 50 minimum of 50 non-urine enterobacterials, we can set like that. You tell.
Yeah, you have to define. Otherwise, the centers will start submitting more
Yeah,
of
I agree. All 100 will be in urine isolates only.
at least 80-90 will become urine isolate if you don't define that.
Yeah, no, we'll define if, in the study protocol. We'll define the minimum number of non-urine enterobacterials tested by this method. Definitely.
Yeah.
Sir, but for Pseudomonas, CLSI doesn't have MIC for fosfomycin. No?
In this study, we are not including Pseudomonas. If have UCAS breakpoint 256 and 512 as a cutoff, ECOF. But for this study, we are not including Pseudomonas aeruginosa in the Fosfomycin test.
But QC, we are using it as QC.
QC we can use, ma'am. Not a problem. So QC ranges, ATCC QC ranges versus clinical breakpoints, they are totally different altogether. So QC ranges can, for Pseudomonas aeruginosa ATCC, what is the range is given, can be very reliably used. That is totally different from clinical breakpoint. Not a problem.
So clinically, can we use UCAS guideline or for reporting purpose?
Yeah, the only thing is, ma'am, very rarely we land up in a place where no other drug is susceptible. Only and it's a PDR. Suppose it's a PDR Pseudomonas aeruginosa, and you don't have any other even ceftolozane, tazobactam, etc. If you test, that all come resistant. Then a fosfomycin can be interpreted using ECOF and informed in the same way to your clinician that it is a ECOF breakpoint, it is an in vitro data generated breakpoint, but because we don't have any other susceptibility.
What is the advantage? What are the advantages of VDRL test?
So this is how we go about ECOF interpretation as a clinical breakpoint or reporting to the clinician for therapeutic use is restricted only in cases where no other drug is coming susceptible using the clinical breakpoint. So the same rule holds for Pseudomonas ECOF also.
Okay, thank you.
So in a 9 centimeter MHA plate, maximum how much number of spot inoculums can be done?
On an average, ma'am, 12 to 15 you presume.
12 to 15, okay.
Yes, sir. Yes.
Yeah, क्या हो गया पूरे
Sarvanam?
क्या हुआ
Sarvanam.
Mute.
So, any other doubts? Entering the raw data, that is disk diffusion zones and MIC is very essential. Correctly, in not just interpretation, you have to make sure that the raw data is of VITEK MIC, raw data of your modified Agar test MIC, and disk diffusion zones are correctly entered into the Excel sheet along with interpretation. That is very much important part of it. Okay, Siva sir, you have any query?
Ketan, am I audible?
Yes, sir. Yes, sir.
I just want to make one note, like as we said in between, right? All gram negatives, because the query came regarding cholesterol Agar test, right? So it is not all gram negative. It is like, because when we are training the technician, all gram negatives, then they will put for all gram negative which are intrinsically resistant also. So that should be like properly mentioned, which are all the isolates of gram negative should be put up and which are all the things should not be put up.
Yes.
So we will discuss tomorrow in the protocol, but just as it was mentioned, so just I want to make a comment.
Yeah. So 2 points to add to it, Siva sir. The instruction goes how is what I believe, I'll tell my point is at what stage you are doing, like for example, fosfomycin or colistin. I'm taking in both sense. At what stage you are doing the testing? Okay. If you are a privileged institute, you'll have MALDI-TOF. If you have MALDI-TOF, usually your AST is put with your ID available. Okay, because the moment you'll have a growth, you'll have your ID in another 1 hour or so, and you have an ID, and you put your AST curtailed to the perform your ID curtailed to your ID. But problem is with VITEK ID, VITEK ID plus VITEK AST or any other methodology of this, ID is usually not available at the time you decide on your AST testing. Now, what is the level of putting your colistin testing or phosphomycin testing? That is what I told. If you want it to be the results to be available along with your VITEK results, so that you can compare and report to the patient colistin result or as well as phosphomycin as a documentation, then you need to put it before your ID is available, because you'll be putting VITEK ID, VITEK AST, any other supplemental testing, and interpret all the things simultaneously. Now that's why with ID doing is not sometimes not feasible. What is feasible is your instructions should for the your technician is very clear cut. You put for all GNB, whichever you process for 405, whichever you process for 406, you put. The person who is interpreting on the next day, who has the ID, VITEK ID or conventional ID available, who has the VITEK AST available, and who has the CAT or phosphomycin agar test data available. It is the onus is upon that person. That will be a resident, senior resident, faculty, or anyone. The onus is upon that to interpret only those where it is recommended. Don't interpret in those where it is not recommended. Exclude the IRs, exclude the no breakpoint available, all those things. But you can't differentiate at the level of before ID to the technicians. So either you have to put for all, interpret selectively wherever it is supposed to be interpreted by the faculty, by the senior resident, or you test on the next day. You test it on the next day. Now testing phosphomycin on next day is okay. I totally agree it's okay, because phosphomycin you're not reporting routinely to the patient. It is done for a study purpose. Colistin CAT is it is a test which is done for patient reporting. Even if you're part of a study.
I just want to make one comment, because for the sub-study aspect I am speaking, because it's not about like routine implementation of the test. Why I am telling, because we are already doing CBD. That is a achievable one. However, we are doing one test for colistin. So we are not going to compromise our reporting system in any point. Just for the sake of sub-study aspect, I am commenting that, because we are like the centers, because the centers are procuring the powders and other things. Already the isolate number will be less. Like we are recommending 50 to 100 or 100 to 150. So if they have to put up for randomly every isolate, it is we are going to land up in lot of isolates, which is going to be intrinsically resistant. So we are not going to make any.
The center. Yes, sir. Yes, agree. Totally agree. So center has to decide. That we'll discuss subsequently tomorrow. But center has to decide in these kind of tests. Center has to decide what is the purpose. Are you going to use this result for patient reporting, or are you going to use these kind of tests only for antibiogram generation, AMR surveillance, or all? If you're using this only for AMR surveillance, subsequently you get the ID, do a repeat testing on day 2 and all those things. If suppose you want to use these kind of tests on patient, then you do it on day 1. That is how the thing goes. So center has to take a call. What's the purpose of doing the testing?
Then I'll add something, because phosphomycin and the colistin study, both these studies are for evaluating VITEK. Therefore, it is, in my point of view, it is absolutely fine if the centers will store the isolates and do together also.
Yes, sir, I agree that.
Because our purpose here is not for the patient care. Patient care, as Siva told, RCBD already we are doing, so that will go to the patient care. And phosphomycin also we are now evaluating whether so even for a higher center or a low volume center, doing all these methods together on a live basis is going to be a challenge. So they can always store the isolate, do it together, in over a weekend or over a week or so, they can involve the resident group or the technician group to do the test. Even if they do that, also is acceptable, right?
For the study, it is acceptable, sir. Like for
Not
routine
for
care, we are not.
colistin, not for colistin, I believe, sir. Fosfomycin, I'm totally agreeing with you. Fosfomycin is something which is this study is a totally R&D based study. Neither we recommend VITEK for reporting, nor we report and want you to report straight away this testing methodology to the patient. So it's a Fosfomycin study is a pure R&D based study. We'll evaluate the data and then we'll take a call. Colistin, CAT, or CBD are standardized method which are to be reported to the patient. So if a center uses CBD on a routine basis for reporting to the patient, because supplemental testing for VITEK colistin is compulsory. It's a compulsory thing. You have to do for patient reporting. If you are doing CBD, then keep.
CBD or CAT, all centers are doing.
Yes, sir. So if you're using CBD as a routine methodology, which you are doing on a live basis, then CAT is optional for you. CAT you can do subsequently. But if you're not doing CBD on a live basis, doing CAT on live basis makes totally sense. So any one test must go on a live basis, either CBD or CAT.
Yeah, I agree with
both
this.
Both the tests cannot go pooled up. Any one test, be CAT, be CBD, one of such tests must go on a live basis along with VITEK. The other test can be done subsequently pulled up. I totally agree.
Yes.
Okay, fine. Anyway,
any other queries regarding Fosfomycin? Yeah, separate discussion. So Fosfomycin, any other doubt? You can procure 1 gram Fosfomycin also if your budget is low. However, 5 gram Fosfomycin, if your plan is just this study and not subsequently at all keep testing Fosfomycin, then 1 gram Fosfomycin will also do the job for the count of isolate we want.
1 gram 100 will be sufficient, Ketan, because
1
now
gram 100 will okay, sir. It will fall.
5 plates, no?
No, 1 gram may will have some somewhere around 30-40 plates. So easily it will cross 100 easily. Not a problem.
No, we require now 5 plates per strain, no?
Yes, almost 3 ml of stock is used for one set preparation. Okay, this and 10 and 100 milligram powder is used for 10 ml. So that is 100 milligram powder is going to give you somewhere around 30 plates. So it's enough, more than enough. 1 gram is enough for 150 sample or 200 isolate sample. 1 gram is going to solve.
And 1 gram,
1 gram is around 4,500 rupees only.
Yeah. So if you want to continue, don't want to continue, you can go with 1 gram and just finish the study. If you the only reason of buying 5 gram is if you want to continue it further. If you don't want to continue it further, just submit 150 isolates and done with Fosfomycin study. Then 1 gram is okay, sir. We can definitely get 1 gram. No need
1 gram is 4,700 and 5 gram is 12,000. So if they don't want to continue further, then they can buy 1 gram.
Yes.
But if they have intention of continuing further, then 5 gram buying makes sense.
Makes sense. Correct.
So only for the study, then buy 1 gram, 4,700. Or you want to continue further, then buy 5 gram.
Exactly.
Centers are in a very confused state because they are not asking any questions.
No, actually, we are at fault, sir. We tortured them with the MIC calculations. Those are very crude calculations. So they may be recovering from the shock of it. The point is very easy. Take those data, make a small printout, and just those messages this to be added in this gram to be added in this. That is the final thing. We discuss those things because we should understand the concept, why something, this gram, why that gram, why this ml. But for the implementation sake, it is only this gram added to this ml and you get this. So that can be written as a short note on a paper, take a printout, stuck it on the media wall so the technician can do it. At that moment, we did not do these calculations, why this range, all those things. That's for our understanding. Okay, then, sir, nobody is asking any query. So we will have a short attendance. Those centers who have joined late, who have not marked their attendance. One I can see in the chat box, Dr. Pragya ma'am, 126 VMR, she is marked attendance. Any other center who has joined us late have missed the attendance?
Yes, sir. NHL VMR 139, sir.
Yeah, 126 also you mark. 126.
129 also,
139 we
sir.
marked, sir. 139 we marked. 126 also.
129, sir.
129 also you mark. Any
54,
other center?
even 54 again, just check.
We'll check.
Start date, Ketan, will be May 1st for those who have the powder or they are going to procure the powder immediately. And for those centers where a little bit of time, they can join the study once they procure the powder.
Yes. Yes. Correct.
Anyway, there is no particular timeline. I mean, they will do the test individually only, so they can also pool the isolate till they procure the powder. They can pool the isolate also.
Yes.
So pool the isolate for a week. Once it becomes more than 100, first you standardize and then you start putting the test. So in that way, it can easily be done.
Yes. Including Enterococcus faecalis and Pseudomonas aeruginosa will help you standardize your plates much better. So minimum, if you want to include 2 ATCC, then include Enterococcus faecalis ATCC and Pseudomonas aeruginosa ATCC. That makes more sense. VMR 54, we have marked already, I think.
Yes, sir, we have marked. Okay, thank you.
Sir, one question, sir, I want to ask that regarding the publications of this study. You will publish this study, or what will be the future plan of action after completion of study regarding the data and everything?
Answer this, Ketan. Publication for all these individual sub-studies will be done separately, including those centers who are the part of the sub-study. But however, you can always extend the study at your center, and with a larger pool of data, you can your own data you can publish also. That is the dictum we have kept in phase 1 also and phase 2 also. Your own data you can always extend. See, don't publish with the same data what you have submitted to the study. You can always extend the study at your center, and suppose 100 isolate data is been given to the study, you can always extend to 200 250 isolate data, and you can publish it individually also. But as a study purpose, we will for all the sub-study, we will include only those centers who have expressed interest and who have completed the study. Those will be included.
And we'll be analyzing the pool data. We won't be analyzing individual center specific data. We'll just pool the data, everything, and pooled data only will be analyzed. So your individual data, if you increase further, a little different from that, and you can extend the study 1 month, 2 months more, and every center can publish the same study. You'll have the tables ready. We'll have the tables. You can use almost same pattern of table to.
There won't be any official communication from us that you can publish your data, because there the ethical concern is there. Unofficially, you can always extend the study and you can publish.
Thank you, sir. Thank you, sir.
Okay. Okay, then Ketan, I think all centers have clarified the doubt, and they can call Dr. Charu also individually, or
Yes.
Sarvanan also is there. So
Yes.
they can call both of them. They can call you also, Ketan, and they can always clarify that. Once they start, the video of this Sarvanan can post in the group, and once they procure the powder, they can watch the video again. And that time they have any doubt while clarifying, while diluting
We'll
and
share the
preparing the
PDF version of the
Fosfomycin.
PPT.
Yeah. So PPT and video both will share. Still, if they have doubt, they can always call Ketan, Charu, or
Yes.
Sarvanan.
Yes. Yes.
Yes.
So, Sarvanan, can you tell what is the total count, total centers enrolling for the study now?
As of now,
After
20, sir.
20. Okay.
20, but the maximum participants here came as 33 centers were participated in this meeting.
Those who have joined this meeting, I hope that those only are serious about the studies. If somebody
How many participated?
How many participated?
How many participated
in this meeting?
33, sir.
33, but 20 centers have expressed interest.
Yes, sir. But some centers are joined in between and they left the meeting in 10 or 15 minutes, sir.
Sir, maybe co-investigator have also joined, sir. That's why you got the more number. From one center, you have co-investigator also.
We have marked the attendance. So
Percentage you can see.
those all P we have marked institutes. Those are the participating institutes.
Yes, sir.
That is the count.
Yeah. Okay, fine. You can drop a message in the group, Ketan, if any other centers who have attended and we have not taken their attendance, if they want to enroll for the study, they can always do.
Yes.
Else, if no other centers are there, then you can close the center enrollment to 20 numbers.
Yes.
And 20 centers, 100 isolate, we will have around 2000 isolate data, and that is going to be a milestone study to decide whether VITEK is good enough for Fosfomycin or not.
Yes. Yes.
Okay, fine then.
Thank you, sir.
I'll close the meeting. Yeah, thank you.
Thank you.
Thank you all.